Alright, hello everyone. This is another Arduino video. Excuse me. Again, it'll be focusing on the code aspect. Basically, I'm going to be making a series of four sections of video that kind of go along with the programming digital media course and its four main sections. Um, or I guess three and a half. We kind of combine some things in this section, but anyways, I'll be making four different videos, each of them with two parts for a total of eight. I already put one up on YouTube, and that was talking about digital signal. But like this one, it is only focusing on the code. So I'll differentiate all of those, but then I'll be making separate videos focusing on the circuits that go along with that code. So you'll see again some videos on code, some videos on circuits, and then through the magic of video editing, I'll combine them together into one cohesive unit. But just for the sake of getting the content out to you all and the teachers and everything, I'll be posting them as I make them, and then I'll combine them all during this upcoming week, and you'll see those posted over the next few days. So with that being said, this is the second code-focused video talking about analog signal. So I have on the screen here, and if you've paused it and read it or are about to, basically it's just talking about analog signal. So before we talked about digital signal, which was there either is or isn't electricity. That's the core concept to walk away from, or doing stuff based on the presence or absence of that electricity, nothing else. Analog is a little bit different because this comes into the question of, well, how much electricity? So the various kinds of Arduino boards will vary bit to bit, depending on how basically how powerful the processor is on that Arduino is kind of the short version of it. You'll have your chip on there, which if I pulled up the Arduino setup page, I've got it all labeled. You've got this kind of IC chip right here on your Arduino. And again, if you're not using an Uno, it's still going to be there, but it may be in a different spot. It may be a different chip. They do vary, but again, I'm going to be going forward assuming you have an Arduino Uno board. But here is the chip that is doing all of the stuff along with this one over here. They kind of work together and do some things. We don't need to get into the details of it, but basically this is the one that does stuff. This is the one that holds the data, if I've remembered that correctly. But they work together and they do all the bits and pieces. Uh, Hop into Arduino Analog again real quick. But basically, the way it works is that the analog side of the board can detect variations in amounts of electricity in between 0 and 100%. In this particular case, because of the bit, the bit, I say the bit depth, we're not working in audio, but basically the computing power of the Arduino Uno, we have a total of 1,024 different differentiations of the that signal. So we can say, okay, in between no electricity and all electricity, there's 1,024 potential options for how much electricity is coming through. Because again, the computers themselves are digital, it has to go down to its base value of it either is or it isn't this much electricity. So it's defined into these discrete little subcategories of how much power we have on the pin. But we can utilize the map function to set that to whatever value range we need to work with. It's very useful. Again, if you're some boards are much more powerful and can have greater ranges to work with. Some are less powerful. It depends on the model of the board you're working with. But all Arduino Unos should be this range, and I think most of the Arduinos are. But again, there's some variances. Um, the core of what we're going to be doing here is voltage dividing, which basically means we're going to send, these are all showing voltage dividers right here, but basically we're going to send um, power from the the battery or the LED, not the LED, the computer or whatever. The power is going into the circuit and through a resistor, and then we're going to measure that voltage in between that first resistor and a second one before it goes to ground. All right, and these are just different ways we can arrange all of that. But basically, by changing the value of one resistor and keeping everything else the same, it will change what that voltage output that we're measuring is. And here's the math with it. You can calculate the thing. So, the voltage output is equal to the voltage input multiplied by, the one resistor divided by the other one and the chain. That's the math. So you can work out all of this and figure out what you should and shouldn't expect in terms of voltages. Um, that's great. Whether or not you go into that in a lot of detail, I'll kind of leave that to you as the teacher and the students. But this is the math involved to work it out. In order to see what's going on, we have a few special little sensors and components that we can utilize for that. And this is going to be a very broad statement here, but generally speaking, in the Arduino kits that you have things with these 3 pins, and you can't really see the 3 pins on this one because it's laying vertically, but this one also has 3 pins. But generally speaking, they will have a voltage divider built into it. The potentiometers here, they do, and these have little knobs, and basically you have the input voltage on one pin, if you see my mouse, and the output voltage on another. And then this is the pin here, this middle one that we're measuring. And as you turn the knob, basically it just moves a little piece of metal around in here, and it just creates more or less resistance that we can measure here on this middle pin. Again, that's a generic statement, but again, all potentiometers that I've ever come across have had it. So again, it's input and output, and then the middle pin is the one that you measure. They have different kinds of shapes and sizes. Sometimes they can be sliders. Sometimes they're exponential. Other times they're linear in terms of resistance changes. It varies, depends on what you need. You got to see what comes with your kit. Also, it doesn't matter what direction it is. So if you turn your knob to the right and your numbers in your Arduino go down, you can just take the component out, rotate it 180 degrees, and stick it back into your circuit. It'll still work, just the direction is now flipped. All right, so to wire it up, we'll get into the wiring a bit later. Again, they're really straightforward, I think, in some code bits. But I just want to point out that, again, other types of potentiometers and things, you may have some pressure sensors. So as you press on different parts of the strip here, the resistance changes and we measure it. We may also have components with these 2 leads coming out, and basically these will work the same way. They're variable resistors, so again, they can change how much resistance they have, but they don't have that built-in fixed resistor to make the voltage divider in one component. So we'll have other things when we focus on the circuit video, and that will, but we have to add in that extra resistor in order to get it to work. There's a bunch of different kinds of sensors we can use, and we'll talk about all those in a bit more detail when we get into the circuit aspect of this. So let's talk about the code. The code is pretty straightforward. I still have this old one from the last video I just did. So let's just make a new one real quick. I'll make that bigger. And let's talk about what goes into the code for analog stuff. So we first have to tell the Arduino what pins we're looking at. So const int, just like before. And we'll say, I don't want to spell potentiometer, so I always abbreviate it to pot pin. My students always get a kick out of that, so I'll let you do that information, do whatever you want with that information. But we're just going to assign it a number. But because it's the analog pin, we have to add something to tell Arduino this is the analog pin, and that is a capital A. And then we have on the Arduino Uno, I think we have 6 pins, A0 through A5. So just A0, just like that. That'll work great. Because the analog pins on our Arduino are input only, let me find here. You'll see on the Arduino it says analog in. These pins only receive electricity. You cannot send electricity out the analog side like we could the digital side. So we don't have to use pin mode because these can only receive electricity. So if we hop back into here, we can set that up. Um, and then we'll say, not const, int hot value, and I'm just going to say is equal to 0. Um, and we can then go in and with our code, we just, like before, we look at the value, pot value gets assigned analog read. Analog read functions just like digital read, except it is for the analog inputs. So we just say what pin we want to look at, the potentiometer pin, and we'll store that in a value, and we can do whatever we want with it. So for these, I like to do stuff with the serial port. So in our setup, we can say serial.begin, and for an Arduino Uno, generally having a value of 9600 is what we want here. The short version of this is what's called the baud rate. BAUD is how they spell that. And it's essentially how many bits can get sent through the serial port every clock cycle when it sends stuff through it. So having a larger value means you can send more information through the serial port every time it sends stuff. This has its ups and downs. Basically, 9600 is actually a little bit on the lower end of what can be done. But this is what, again, the Arduino itself is not a very powerful computer. Modern computers have outpaced it since the early to mid 80s, give or take. So again, that's totally fine, because we don't need to manage a ton of info with the Arduino. The Arduino at its core is just sending and receiving little electrical signals, and then we can use other computers that are more powerful to do stuff with that. So again, that's why we're picking this value. It's on a little bit of a lower range. It's just how much data gets sent. This is a good one for the Arduino's processing capabilities. So we can have that there, but you have to tell the Arduino to start that communication in setup, and then we can just say serial.print. I like to do serial.print line. And basically this just prints it and then does a carriage return when it prints it. So everything that you send has its own dedicated line. And this will function just like print or console log in P5. We just tell it what to print. And so, we could do things like, actually I'll do it like this, serial.print, and we'll say pot value there, and then we'll say serial.print line pot value, the variable, and I'll add a colon and a space for formatting things. So this will print out on the same line pot value colon space, and then it'll say whatever the number is, and then because this is a print line command, it will print it out later. So again, we'll see this in action in the circuit building portion of this video, which will, again, that will come out pretty quickly, probably tomorrow. Then over the next week, I'll combine that with this video in order to see it. So starting off, we will work with this code, and this will just display into the serial values what we want to output, and we can see all of that in numbers. So basically, if we go into serial monitor, oh, it got angry at me because it's looking at the wrong port. But we'll look at that more in the other video. Then we'll get into that. But we can see these numbers coming in from the Arduino, and that's a really useful tool. The last bit I want to mention with the code is that you can we can do a lot of stuff with it. So we can go in and we can map some things. So maybe I wanted to say, in I'll just call it mapped pot. And I like to give my things a default value to start with. And we can go into the loop and we'll say mapped pot gets assigned the map function, and here we can look at the pot value. That's the value we want to map. The original range, which is 0 to 1023, and then the new range. So maybe we want to go between 0 and 100. And now you'll have this new range, and basically it scales it, so whatever position it was in between here, it's now fitting into this one. So we can get a kind of a percentage value at the same thing. So I can go ahead and say, I'm just going to copy and paste this actually to save some time. But we can copy and paste this. And now instead of pot value, we can say pot percentage. And this will now be the mapped pot, like so. And I'm just going to do a serial dot, a blank print line, just so that way there's a space in between these two things. So when we see it in the circuit in just a moment, that'll pop up there. So again, this is the core of the code. It's again, the code part is very simple. This is relatively short video after all the explanation bits. This one will be a bit longer on the circuit building side because again we'll be building up. We'll start with a simple potentiometer and the LED. And we may actually I may leave out the LED. We'll focus on the because I'm doing this before I've done the circuit. We'll focus on the potentiometer and the serial port, and then I'll make a separate video because I mentioned there'll be 4 parts to this with the pulse width modulation, because that's kind of a combination of these two things we've talked about. But we'll talk about the code and working up the circuit, all of that with the other part of the video, and then we'll also play around with probably the light sensors and some of these other sensors that require an extra resistor in order to work. And that's where I'm going to wrap it off today. Again, relatively simple. Feels kind of weird that there's not a lot of context with the circuit. So if you're watching these in advance, this may be a little bit weird, but I'll be editing all of these 8 videos together in order to have 4 kind of more cohesive, longer videos that will break down all of the stuff. So stay tuned. They will be coming. I'm going to be trying to get 2 or 3 done a day. So hopefully by, 2 or 3 days after this one by itself comes out, you'll have that ready to go and it'll all be online. So I will see you all next time. Bye. It helps if I click the right button.